Hello everyone, and welcome to the continuation of our industrial warehouse design series using Autodesk Robot. Of course, I want to remind you that this video series is going in tandem with a theoretical video series. And of course, I have one big playlist that covers both in a chronological order, being shown on the top right, because, there is a theory part and a modeling part. So if you want to see the theory behind what I'm doing here, you can check out those videos as well. In this video, we're going to make some geometrical manipulation, add some bracings, and well, take a look on the different aspects of modeling before adding any loads. With that being said, sit back, relax, and enjoy the show. Okay, so basically last time we have reached this position in our modeling, in our multi-parter warehouse model series. And of course, if you run the analysis, if you remember, it's unstable. It's a festival of instability because our purlins now are basically double hinged, so they are unstable. Now, how do I fix that? You fix that using bracings. Now, there are multiple things we're gonna do today. Let's walk into that. So first of all, we need to brace that thing. So how to brace? Well, you go to Geometry, Members, and select Bracing. You can, for example, select a different type of member. I will select here a simple member, which is basically a generalistic type of member. And hey, look, our ZCEE 150-50-20 cross-section is available here because I added it. And if you want to know all about this, you should check out this video linked above about how to define your own sections. Anyway, I will go now my section definition. I'll go to the European code section definitions. I will make me some bracings. Now, once again, this is all about you. The selection of the cross-section of the bracing depends on you. I like to select either bars or pipes as my bracing. You can choose, for example, a plate if you want here, like this is flat beams. If you want to select a round bar, I don't know, you can even select like square hollow tubes for your bracing, and it's up to you to select whatever you want. For now, I will not be focusing too much on the sections because they will change when we design, but I will now, for now, select me just a round bar, just because I want to show you how this is done. Later we will change this, but for now I will choose me a round bar just because I want to see the stabilization issues here. So round 8 has a meaning. I will select a placeholder, round 20. I'll add that, close. This is placeholder. We will design that stuff in the future. So now I want to brace it. Now if you go here and select from here, because I'm going to make an X bracing, I will brace the first bay and the last bay. So here is one bracing, and here is another bracing from here to here. So we have now two cross bracings. Of course, this is a joke of cross section. We need to modify it later, but now we have two cross bracings. So if you run the analysis, suddenly robot stops hating you for the cross bracings. What's this? Parameters of the material used. Okay. I was too fast. When I defined the cross bracing here in round 20, I actually didn't select the correct steel. I wanted to select 275, right? Steel 27. There we go. Steel 275. Let's just overwrite this because I want to use the Eurocode steel. Okay, let's run the analysis again. Okay, there we go. Fine. So now I have my. You see, the idea is that you should be a little bit careful when you model. Look, the idea is not only to look cool, it must make sense and be able to be done in real life. Like now I'm thinking about the connection here, to be honest. And I'm thinking, how do I connect that? Should I brace it a little bit lower? Now, those little changes, to be honest, if you want to brace it a little bit lower, a little bit higher, those are things I usually do not put in my Autodesk Robot model. But I'm still thinking about this because there is like a bracing. You need to apply a little plate here with bolts, and there is still a tie beam to be done here because we discussed this in the last theory video. So I'm thinking maybe I should be doing the bracing lower, but I will leave it for now. This is something I will leave for the practical issues, not now. Kind of annoys me, to be honest. Now it seems everything is fine, right? The cross bracing solved everything. Well, don't be tricked. It didn't solve everything. The only reason why it solved everything is because this is not a bracing. This is a full-fledged frame now. Yes, I know we added this in the intention of saying this is a bracing, but in reality, this is a full-fledged frame. and that's not a bracing. The bracing usually is released on both edges because we have here a released connection, it doesn't carry any moment, and we have here a released connection, it doesn't carry any moment. I haven't done that, so the bracing actually is carrying now the moment from the frame, which doesn't make any sense. So to do this, I'll go to Geometry Releases, I'll double pin it, so pin, and I'll apply this to both 5 and those two sections basically, 5 and 6. It's odd that it calls it 5 and 6, really? Okay, fine. I'll apply this, yes, and now I have them both braced. Now, if it's stable, then it's stable. And in fact, the structure is stable now because we're not using any trusses. There are some problems that might happen in Autodesk Robot. You see, Robot sees that those members are intersecting at one point. So the question is Robot going to transfer the forces from this bracing to this, or from this bracing to the other bracing? Now the short answer is no, and there is a reason why. But before I do this, how do you check that? Well, to check this, I'm just going to go to a member load, add me a member load of 5 kilonewtons in the X, and at distance, for example, 56%. I'll add this and add here a force. This is only a little logic check. So now I have a force here, right? So let's run the analysis and see what this Purlin and the other Purlin feels. So if you go to results, diagrams for members, now if you open the local axis, you can see that for the bracing, this force will cause moments around the z-axis of the bracing. So I'll open MZ and hit apply button. So I cannot see it, so I need to increase a little bit in the diagram size. Okay, now I can see it. And it seems that this force affects only this bracing. The neighboring bracing, as well as the neighboring beams, are not affected by this force. Let me open torsion. No effect. Okay, this torsion is because of Purlin's own weight. That's not the point. My, let's take a look. Yeah, there is my for the portal frames. That's normal. But I don't see any moment transfer from one to the other. Let me just label and differentiate and fill just to see things clear. So I think, yeah, I'm so far okay with this. But the question is, why didn't there happen any force transfer between those bars that intersect and the force here? The reason lies within the calculation module of Autodesk Robot. If you click on Analysis Parameters, which you can access via this button, I think, or to go to Analysis Types or something, I think, or yeah, the same thing, you can see that in the structure model, you're actually telling Robot not to create nodes at the intersection of diagonal members. So if there are two members intersecting not at 90 degrees, the intersection will not be seen by Autodesk Robot. If you click this, then it will be seen. And now if you click this, those members will be connected, all members will be connected to each other, and there is force transfer between them. Allow me to show you. You see now, okay, my values are all over the place, I guess. So give me a second, I need to clean this mess up. I just go to diagrams members, normalize everything. Okay, and you can see that suddenly you have a mess here. The mess is being caused because the force here creates moments, and those elements now are connected in this point. So there is moment transfer, there is a rigid joint, meaning that this bracing sees this bracing and interacts with it. Also, those two bracings see this beam and interact with it because we asked it to create a point. If you remove it, then, well, things go back to normal where they don't see each other. And I don't need to normalize now because I can only see this moment. Now, this is one thing. The second thing is, you see, you could mess it up even if you ask Robot not to connect those things. Like here, we are asking Robot not to connect members that do not intersect at 90 degrees, meaning that it only connects members intersecting at 90 degrees, which is something we want because we want to have a connection between the bracings and purlins and so on. But you can actually mess it up even while having everything right here. How? Well, if I go to node and add me a node here, then if you run the analysis, you go back to the initial problem. It says isolated node, but wait for it. You go back to the initial problem where you have a mess here. Why? Because you put a node here. So now Robot will try to fulfill your wishes by splitting all the beams at the node. And here there is no option. Like here there was an option, like you can create, But now there is no option. You put a node here, so robot thinks, okay, you put a node, it means that you want those members to be connected. Now I deleted my node and run the analysis again, and now everything is fine. We're back to normal. So yeah, those are little nuances. Like, the problem is that if you don't see this, you think that everything is perfectly fine and you're doing a great job, but in reality, it's far from having a great job. So okay, that's my first bracing. Now, of course, I'm used an X here, but you can see here in this picture and in this picture, it seems that the standard practice is using V's for bracing. Now, why is that? It's a really cool thing, to be honest. The V's seem to provide some lateral stability for the column, because you see when you put an X bracing, then the lateral torsional buckling length, so the length upon which you're going to buckle your column, is actually the full length of the column if you make an X bracing. But if you do a V bracing, then you are reducing your column length because you're bracing the column at certain intervals. Similarly, for the rafters, you would reduce effective length of the rafter. And also there is something about the stabilization of the lower flange. At least for those two rafters, you don't need to stabilize the lower flange because you're already providing bracings which both brace the structure and provide stabilization for the lower flange. Notice also, I was kind of annoyed about the stabilization point, and I said that I said that this connection is kind of annoying for me to realize in real life. You can see that that's true, and you can see the bracings are actually not at the exact edge, but a little bit lower. I think I will do this. So how do I do this? Well, I'll just delete that first of all. Okay, so I'll go to Edit, Divide, and I'll add me a point at 30 centimeters from a distance. So I go distance here, because I will still use the cross bracing, but I want to be a little bit more practical oriented. So now I will remove this because I want to see stuff. I'll click here, and I have a node here, and I'll click here. Of course, the question here that I can see is, do you really have to do this? Couldn't you just simply connect the bracing with the point here? The answer is yes. Those little changes do not change a lot in the structure, but the reason why I'm doing this is because I want to be a little bit, accurate. You don't really have to do it. You could just perfectly fine sit with a bracing, an X bracing that starts from the beginning to the end, and that's it. But well, to just satisfy the little perfectionist inside me, I'm just going to make this. So okay, fine. Let's just do this very quickly. From here to here, that is one of them. And from here to here, that is another one for them. I have my bracings. Of course, those are now incorrect because I need to release them. So, well, I go to Geometry, Releases, and now I want to release them by using a double pin. What do I want to release? Here is where the selection tool comes into mind, and I click selection tool. I want all the things that are drawn by round 20, and then I will click here, it implements a selection, you apply, and now they are released. And that's the reason I use different sections. If you run the analysis now, just to be sure, isolated node, no, it's not. There is no isolated node. So I think everything is fine. And we mentioned, let me just double check. I think we mentioned that, yeah, we have removed this, so yeah, everything indeed is fine now, and it's stable. But that's not enough, because we need to stabilize the roof. So I will stabilize the roof using V's. I hope I can do it, so let's see. 1. So just stabilize the roof using V's. I'm thinking loudly here. How do I do this? Well, let me see. So I go here now and go to my bar again, or my simple bar, so Geometry, Members, to Simple Member, and now I'll basically draw it. So I will try to avoid this, and I will select near the Purlin. You think, wait a minute, you moved away from the Purlin here. Why do you not move away from the Purlin here? Actually, I should not have moved away from the Purlin here because the Purlin is in a different plane than the bar. Look, the Purlin is on top. The bracing, like look here. The Purlin is on top and the bracing is below it. But still, I think you are right. So it makes more sense if I actually change a little bit from the Purlin, just move away from it. Those are nuances that I'm thinking about at the moment, but I could just simply make an X bracing and that's it. And I kind of don't like having an X bracing just like that. So now, will it work? The answer is unfortunately no. There is more to it, because when you add a cladding, things will go crazy. Because now, if you add a cladding, those elements will feel the force of the cladding, but this is something for next time, because I cannot do everything in one video. Now, I have explained the nuances, but now I will just do my bracing like this. I've already explained the nuances about it, so I hope that you don't mind if I just go on and do a simple V bracing without paying attention to the nuances of the practical issues with regard to connection. Because I've already explained that, right? I've explained that you don't even need to do this. But I'm still satisfying the little nerd inside me, so, well, let me do it too here. So, okay, we have our first cross bracing here. I'll now do it here. It's not cross bracing, it's V bracing, actually. And I know there is a question about the member type, but I will wait for it when we design, so I will leave it for now. So we have our cross bracings. Of course, those cross bracings are incorrect because, once again, I have not released them. So, of course, you should draw your entire bracings first and then release them. So I go to Geometry, Releases, and first of all, I need to select my cross bracings. So I click on the Selection tool, double click on the round section, and now select everything. Click here, Apply, and now I have my round sections being released. Run the analysis just to check, and it works perfectly. So I have now done my cross bracing. What else do I have still to do? I still have to do the tie rod here, or the tie beam here, and the tie beam in the middle, and the tie beam on the edge. Now, do you have to do that? Well, not all of them do that. I've shown you last video in the lecture series that not all of the designers do put a tie beam. I will do a tie beam because why not? So I click on the beam here. I select me a steel beam. I select me I'll add me a steel tie beam. So I just go here and basically select me a family of I just select this family now, and equal angle legs. No, I think there was something like here, T-rectangle, rectangular hollow tubes. Add me a placeholder, for example, this 50 by 30, 50 by 30 by 4 millimeter section. I'll add that. Of course, I messed up because I forgot to change the steel. Now I will change it because I don't want to make the same mistake all over the place every time. So 275. I'm assuming steel 275. You can select any steel you want. And I'll assume 275 normal. So I'll add that. I'll overwrite. Yes. And I'll close, and now I'll draw. So I'll draw from here to here. Let me drag this. So 1, that's 1, that's 2, 3, and so on. Truth to be said, I could have saved myself the time if I had dragged the entire portal frame correctly. I haven't, so now I'm paying the price in terms of time. And that's the rectangular cross section. Okay, fantastic. You notice that I'm only using placeholder sections here because we will be designing them, so they will change. So okay, I just continue dragging and drawing. And I would do a crest tie beam if I want. Now notice this is yet only one suggestion to you, because there are other portal frames where there is no tie beam in the middle. But I'm just going to do that. Remember, it's your responsibility to come up with a structural system that is safe and stable. And I'm trying to explain not that some things, look, I do things, but I explain that you don't have to do this. This is not a must for you. Now, here's the thing. We're going to offset now. The tie beam is in the center of the element. You can see the tie beam being in the center. There is nothing about it. But the purlins are not in the center. So we need to offset those. So I go to Geometry, and there is a video talking about offsets and the meaning of them. I will link it on the top right. So now I will offset those things. Now I just go to lower flange and click here. Oh, sorry. No, that's not enough. That is not enough. Lower flange is not enough. I can offset the column to make it fit. Lower flange, sorry. I can select the column, and then it works fine. But then what only works fine are the purlins, because the bracing doesn't work fine, and the tie beam doesn't work fine. So offsetting a column will not make any sense. So I have to offset my beam. Now, if you select lower flange, it will only shift the lower flange a little bit upwards in the beam. But that's not enough, because it should be more than the lower flange that we should offset, because we want to offset a lot more than the lower flange. So I select here and select my offset, and I want it to be relativistic. I want it to be relativistic to the section. I want to offset here relative to this, and I'll add that. I'll add here, and if you click now, we are back to offsetting only the lower flange. That's not enough. I want to offset more than the lower flange. So it seems I'm stuck, right? You have zero axis displacement, meaning that now you are offsetting only the lower flange. Now you can offset it more. How do you offset it more? You can offset it with respect to an object. So I want to offset this with respect to this object. So you can click here and select the object, and now you are measuring with respect to this object. If you click add, which will overwrite your offset, nothing seems to happen. Why? Because you are basically offsetting, and this is something you need to check multiple times. You are offsetting with respect to the center of this object. Allow me to explain. Let's put everything back to zero, just to show you. If you put everything back to zero, and even if you offset with respect to this element, nothing will happen. Because, well, you are offsetting the center of your element with respect to the center of your other object with a distance of zero. So nothing will happen here. Let me show you what happens if you click on the top side of the object and click OK. If you add it now, then you can see suddenly that the first offset that happens is because now you are offsetting with respect to the top side of your section, which is at least a good start here. But that's not enough, because now still you need to put your purlin above this section. So if you want to put your purlin above this section, you have to go to your own section and ask it to position it in the lower part of your section. And that's what you want to see. And now you have your offset correctly done. So it's something weird. You need to get used to this, but that's what I will be doing anyway. So I'll close that now, and I close this. I forgot, I think in the display settings, I can open the offsets. Yeah, there we go. I'll apply that. There we go. So now I will repeat this process for all my purlins. Now, luckily for me, I can do that because, and this is important now, I'm offsetting with respect to the cross-section of this rafter. So I have to keep the cross-section of all rafters the same. Otherwise, I would have some weird offsetting happening here. Luckily for me, I will stick to this in the design. I need to keep a mental note of that. But I will make one beam section for all the rafters. So I go to geometry offsets now. And please notice there is an offset video talking about the meaning of those offsets. Please take a look there if you want to basically get some stuff behind. So okay, I'm just clicking now. You know where this is going. I think I should video edit this. Or maybe, you know what, maybe I will upload a ready Autodesk robot file. And you see, this is what I talked about the sections. I'll upload me a Autodesk robot file that has those offsets done for you. So I'll just show you one part of those offsets. So there we go. Notice I'm not offsetting the tie beam. The tie beam by definition is in the center. So I offsetted those purlins. What about the rest? Well, those now I cannot just click on, will it work? It shouldn't. If I click here, it shouldn't work because the section is different. If I click here, yeah, see, it's totally wrong. So I'll just basically remove the offset here and think about this in a moment. So what do I want here? Well, I need to, first of all, add me, now I should rename this, my rafter offset. And now I will add me an offset and call it my column offset. And now I have to think again. So I'll just add it blindly now. And there is another idea. You can do a try. I mean, I've explained the idea here, but you can still do a trial error if you want to do offsets yourself. So for example, I can select my column offset right now, click it here for this one, and now do my painstaking trial error process. So I double click on that. I go to relative. I don't like this, to be honest. Before I do it, before I continue anything, I just had a thought that this is actually not the correct section. I need to rotate it 90 degrees, right? So let me just very quickly do this. I click here, and I'll go here. There is a gamma angle somewhere here, I think. Let me just check. Gamma. There we go. There's the gamma angle here. I'll just add 90 here. I could change the gamma angle. So now it's rotated 90 degrees. That's the first step. And now I have to offset that stuff. You see, this is what makes you special in Autodesk Robot. If you know those little nuances, I know that some of those things I do are an overkill in accuracy, but I try to achieve with you the highest levels of accuracy, and feel free to underperform. It's okay if you want to reduce some of those things because you think this is too much of accuracy. I agree. Some of those are higher accuracy than usual. Okay, so I just click here. And now, well, I go to relative here. I'll now ask it to take the lower side, okay? And for now, I will select this object because that's my object of interest. And I will now let the axis offset be on this side. Will it work? I don't think it will work. No, that's incorrect. I want it on the top side because it's still the top side, right? Or the bottom side. I forgot how I drew this. Well, trial error, right? I'll just add that. And yeah, now it's working. Okay, fine. So now I'll just close it here. I have my offset. I can stop offsetting everything. I'll offset only those. Wait, what? Okay, yeah, I need to click, okay, close, click away. And then what do? I click here, choose a gamma angle of 90 degrees. Those will work, but will the left side work? Well, I don't know. Let's just apply. Well, those worked. And will the left side work? No, it doesn't work, the left side. So, nah, that's annoying. Oh my. So I have to do this like my column offset right. And now I have to make a new one and call it my column offset left. Once again, I know I'm overkilling it with accuracy. I know. I'm very well aware of that. So now I will flip everything. I flip this here. I'll flip this here because the other side. I'll add this. And now I will choose those. Let me try it. Let me try it very quickly. Click here. Yeah, perfect. It works now. Fantastic. I have everything. Great. What about the rest? I'm gonna video edit this and release the improved version on the channel. Oh wait, I forgot something. I forgot to change the sections to cold form sections. Shout out to our engineer Donald Khania. Now you can, if you click on sections and select sections here, if you go to the European section database, there is no Z channel because I will make a Z cold form section for the Purlins. There is no Z channel in the European code. There is in the AISI, this is like the cold formed steel manual of America, but there is no European section that has a Z. Now, there are two options for this. Option one is some kind of lazy option, in which you go to database or you just go to the section database like this, and add yourself an Australian section or something. Like if you go to the Australian section database, you can see that the Australian section database has Z channels, cold formed Z channels, mind you, and you can add those. For example, you can go to Tools, or you can go here to Tools, Job Preferences, go to your databases, to your sections, and just add yourself the Australian section, which is, I think, this, Aussies. Yes, I'll just add that. And now you have it available for you, AUS. So if you go to the sections again and click here, you should be able to see the Australian section database. I cannot. Why? Hold a thought. I have a thought. Maybe it just takes the first four databases, I guess. Let me just check very quickly. Let me just take this up. Where's the Australian? Wait, what? I'm honestly flabbergasted. Didn't I add it? Australian? I added it, didn't I? Right? Oh, there we go. There it is. Let me shift it upwards. I think it takes only the first four data. I think it takes only the first four sections. So I just close and add the section. Did I mess up? I don't think I messed up. So let's click here. Yeah, there we go. Australia, right? Huh. Okay, fine. You go to Australia, you can select a Z shape here, and you can select the Z shape from the Australian section database. This is the lazy way of doing it because I'm using the Euro code. The correct way of doing it is to create your own section from the European code database, or to find a database that you can import on Autodesk Robot. So I have done that before. I have defined my own Z channel. There is a video I linked above before in this video about defining the Z channel, so I will take it. Before I take it, let me show you what happens if I click here. Everything is fine. The offsets still work because the offsets deal with the section centroid. Notice that the offset will flinch to the right a little bit. The reason why it flinches to the right is purely geometrical because this Z channel is not double axis symmetric. But nevertheless, I'll just click on those and now I have my Z channels. This is option one. Option two is to use the Australian database. I mean, yeah, you get the idea. I will be doing this off camera, off screen. Basically, that's everything I wanted to talk about in this video. And before I finish, I want to give a huge shout out to our dear channel members whose names are going to be shown on the screen. I would like to thank them from the deepest of my heart as they support the channel and help us produce those videos in the future. Thank you very much. With that being said, I hope that you enjoyed the video and that it was beneficial for you. If you have enjoyed the video, then please like, share, comment, and subscribe, especially subscribing because it helps increase the reach of my channel. As per usual, this is the Civil Engineering Essentials channel, and we'll catch you in the next video.